Problem statement. The canal shown below is to be widened by L so that the initial water flow discharge can be doubled. Determine the additional width L if all other parameters such as flow depth, bottom slope, and surface material are to remain the same. So here we have two conditions. We have an initial condition and we have a final condition. In the final condition, the flow discharge is double. Okay, and what we are doing here is we are increasing this channel by a length L. Okay, and when we do that, the flow discharge is going to double. So we have a condition one, which is the initial, and then we have the condition two, which can be the final condition. Okay, and the flow in the final condition with respect to the initial condition is going to be double. So the flow into will be twice the initial flow. Okay, and then we have to get what should be L for the flow to double, right? So we can apply the Manning's equation. The Manning's equation is the Manning's equation is Q is equal to coefficient 1 n area hydraulic radius 2/3 the slope of the channel to the 1/2. Okay, so I know that the ratio between the flows Q2 divided by Q1 that will be equal to 2. So the Manning's equation in the final condition is going to be the coefficient C sub 1 times the roughness 2, okay, area 2, hydraulic radius 2 to the 2/3, slope sub 0, 1/2. The slope will not change. Then we have a C sub 1 divided by N1, area 1, hydraulic radius 1, 2/3, and a slope of the channel 1/2. So this is a coefficient C sub 1, which only depends on the units, if it is metric or English, so that will not change. We can cancel that. The problem is also telling me that some of the properties will remain the same. Example, the surface material. So that means that the roughness will remain the same. So N1 will be equal to N2. So we can cancel this. The slopes are the same, so we can cancel those. So basically, the only things that will change are the water depth, and of course the areas and the hydraulic radius, right? So if the water depth changes, the area is going to change and the hydraulic radius is going to change. Actually, let's see, the flow depth is going to remain the same. The water depth is going to remain the same, but the area is going to change because I am adding this L. So if I add L, the area is going to change, and the hydraulic radius, which is area divided by P, is also going to change. Therefore, what I'm going to have here is 2 is going to be equal to area to the hydraulic radius 2, 2/3 divided by the area 1, the hydraulic radius 1 to the 2/3. Okay, that's going to be. Okay, so now I have to get the area and the hydraulic radius for the final condition and for the initial condition. Okay, so let's see first the area. Let's see area 1. What's going to be area before the expansion? What's going to be area 1? Area 1 will be the area of this channel, which is going to be this. So that's going to be a trapezoid, right? A trapezoid. This is the bottom. This is the top. So the base is 4. So if this is 4, I can draw here a vertical line. So this is going to be also 4. The side slope is 2. So the vertical is 1 and this is 2. So if the water depth is 3, if the water depth is 3, this will be 6 because the ratio of the side slope is 1 to 2. So if the vertical is 3 meters, the horizontal has to be twice of that. So that's 6. Therefore, the area is going to be the top, which is 10, plus the base, which is 4, divided by 2 times the height, which is 3. Then the area 1 will be equal to 10 plus 4 is 14 divided by 2 times 7. 7 times 3 is going to be 21 square meters. Okay. And the perimeter 1, the weighted perimeter 1, is going to be, okay, let's see here. The weighted perimeter is going to be this, plus this, and plus this. Therefore, the perimeter is going to be this, which is 3, the base, which is 4, plus this, which is going to be the square root of 3 square plus 6 square. Therefore, the perimeter 1 will be equal to 13.70 meters. Okay, that's going to be the perimeter 1. And therefore, the hydraulic radius will be area 1 divided by perimeter 1, and that will be equal to 1.532 meters. Okay, so now let's do it for the condition 2. For the condition 2. Okay, so what is going to be the area 2? Area 2 will be equal to area 1 plus this rectangle. The depth is 3, therefore the area will be area 1 plus 3L, right? So area 2 will be equal to area 1 plus 3 times L. Therefore, area 2 will be equal to area 1, which is 21 plus 3L. And the perimeter 2 will be equal to, okay, let's see, will be equal to this, plus this, plus this. So the perimeter 2 will be equal to perimeter 1 plus L. So this is the same as this. The only thing I am adding is this, right? So therefore, the perimeter 2 will be equal to the perimeter 1 plus L. Perimeter 2 will be equal to perimeter 1 plus L. Therefore, the perimeter 2 is equal to perimeter 1 is 13.7 plus L. And therefore, the hydraulic radius for 2 will be equal to area, which is 21 plus 3L, divided by the perimeter, which is 13.7 plus L. Therefore, I can plug all of these values in this equation 1, right? So I can say, okay, then 2 is equal to area 2, which is 21 plus 3L times the hydraulic radius 2 to the 2/3. The hydraulic radius 2 is 21 plus 3L divided by 13.7 plus L to the 2/3 divided by the area 1, which is 21, times the hydraulic radius 1. The hydraulic radius 1 is 1.532 to the power of 2/3. As you can see here, the only unknown is L. and we can solve this for L, and then L will give us a value of 5.02 meters. Okay, so we need to um, we need a length of 5 meters to uh, to double the flow discharge.